Okay, so good afternoon, dear students.
Good
Yes,
afternoon, ma'am.
yes, okay. So yesterday we have completed the first chapter, that is from physical chemistry. We have seen solution chapter. Okay, so today we are going to start with next chapter. Okay, so second chapter. So this is a chapter from organic chemistry. Okay, so this chapter, that is haloalkanes and haloarenes. So this
Excuse me,
particular
ma'am.
chapter, yes.
Uh, Yesterday you have done mole fraction. No, ma'am. Mole
Huh,
fraction calculation. That
yes.
is, I have doubt, ma'am.
Huh,
K high.
okay.
Calculate the K high of mole fraction. I have doubt, ma'am.
Huh, yes. Okay, you can ask. Wait, just a second. I should open that PPT.
Sure, ma'am.
Mm, mm. Or what we'll do? You're there in the WhatsApp group? Pavitra. Okay, so what we'll do we'll start with this chapter now. Okay, so at the end, or maybe separately, I'll solve you that doubt.
Okay,
Okay,
ma'am.
okay, okay,
Okay.
fine. Okay, fine. So today we are going to start with a new chapter. So that is from organic chemistry. Can anyone tell me what you mean by organic chemistry? Yes, what you are discussing in organic chemistry?
Organic chemistry is the branch of study hydrocarbons.
Yes, hydrocarbons means, what do you mean by hydrocarbons then? Yes, you are right. What do you mean by
Which are
hydrocarbons?
present the hydrogen end of carbon.
Yes. Okay. So it is chemistry means you are studying about organic compounds. So these organic compounds, these are formed naturally. Okay. These are formed naturally. So the natural element like carbon and hydrogen. Okay. So these are made up of so here we are going to discuss, okay, so in organic chemistry, so now we are going to start with the first chapter, that is haloalkanes and haloarenes. Okay, now what do you mean by this word haloalkanes? Okay, and haloarenes. So first we'll see what do you mean by this word. Okay, so haloalkanes. So what do you mean by haloalkanes? The word haloalkanes. Haloalkanes means these are called as uh, wait. Okay. So haloalkane means these are known as alkyl halides. Okay. These are known as what? These are known as alkyl halides. Here. Okay. So alkyl halides. Okay. Now, so these are the halogen derivatives. Okay. These are what? These are the halogen derivatives. Now, suppose I have methane. Yes. This is a hydrocarbon. Is it a hydrocarbon? Right? So this is a hydrocarbon, right? So this is a compound, okay, a molecule made up of carbon and hydrogen atoms, right? So here, what is, so this is a hydrocarbon. So how these haloalkanes are formed? Okay, so one of the hydrogen, okay, one of the hydrogen is replaced by what? It is replaced by a halogen atom. Okay, it is replaced by a halogen atom, then it is called as a alkyl halide. So this results into a alkyl halide. So one of the hydrogen. So when you are replacing one of the hydrogen, okay, any number of hydrogen atom you can replace. Okay, so one hydrogen atom can be replaced, or the second hydrogen atom can be replaced. So so haloalkanes are what? So haloalkanes. So these are the halogen derivatives. What they are called as? They are called as the halogen derivatives. Now, what do you mean by halogens? So halogens are what? Group 17, right? Group 17 in the periodic table. So halogens like what? Fluorine, chlorine, bromine, iodine. So these are the halogen at right halogen ions. So these are the, what do you mean by haloalkanes? So these are the halogen derivatives of aliphatic hydrocarbons. So you might have studied also about aliphatic hydrocarbons, right? In your previous first year, okay, in the hydrocarbon chapter. So we have also discussed there in our CET classes. Okay, so what are the types of carbon? Okay, in that we have studied aliphatic, aromatic, right? Now, what do you mean by aliphatic? So here the carbon atoms, they are in the straight chain. So they are forming the straight chain compound, or they might be in the branch chain system. So like this. So this system, it is called as what? Aliphatic carbons. Okay. So haloalkanes. So these are the halogen derivatives of aliphatic hydrocarbons. So these are the halogen derivatives of aliphatic hydrocarbons in which one or more hydrogen atoms. So either one or any number of hydrogen atoms are replaced by the halogen atoms. Okay. So such a compound. Now such a compound means what is happening here? So methane is forming CH3X. So one of the hydrogen, okay, one of the hydrogen, how your halogen atoms are represent? They are represented as X. Okay. So one of the hydrogen atom, it is replaced by what? It is replaced by halogen. Okay. So halogen atom, then they are called as what? They are called as haloalkanes. These are called as haloalkanes. So in this haloalkanes, okay, where you can see CH3X. So this halogen atom, okay, it is attached to a sp3 hybridized carbon. Now, do you know, everybody know what do you mean by sp3, sp2 and sp hybridized carbon atom? Yes?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Okay, for the students who don't know, I'll just tell you. So sp3 means what? So the carbon atom will be attached to the carbon atom with a single bond. Okay, so this carbon, now the center carbon, this is said to be what? sp3, sp3 hybridized. Okay, so here you can see. So there is a, so this carbon, when we are checking the hybridization, so this is a sp3 hybridized because this is connected to another carbon or the other atoms by a single bond. Okay, now when you have a carbon, a double bond carbon, so when I want to check the hybridization of this carbon, so this is having a double bond. So this is what it is?
sp2.
Yes, it is sp2 hybridized. Now, another example, if I have a triple bond, okay, a
sp3.
carbon, it is sp3.
sp.
It is sp. Okay, it is sp hybridized. So this is the hybridization. Okay. So don't forget the hybridization when we are discussing about organic chemistry, organic any chapter. So hybridization will come into picture. Okay, because when we are studying about the different molecules, different structures, right? So here, so what are haloalkanes? So haloalkanes, these are called as alkyl halides. These are called as what? These are called as alkyl halides, and these are the halogen derivatives. Okay, these are the halogen derivatives of aliphatic hydrocarbon in which one or more hydrogen is replaced by a halogen atom. Okay, and here the halogen atom to which okay, halogen atom is attached to the carbon and it is sp3 hybridized. It is sp3 hybridized atom. So understood what are haloalkanes? Yes, did you understand what I had? Okay, so now we'll discuss about haloarenes. Okay, next is haloarenes. Haloarenes. Okay, now what do you mean by haloarenes? So haloarenes means they are called as aryl halides. Okay, aryl halides. Now these are the halogen derivatives. So these are also the halogen derivatives. Okay, but here what is happening? What is the difference here? Okay, these are the halogen derivatives of aromatic hydrocarbons. Now, what do you mean by aromatic hydrocarbons, students? Yes, what do you mean by aromatic hydrocarbons, students?
Hydrocarbon containing benzene ring.
Yes. So benzene compounds. Okay, benzene compounds, they are called as aromatic hydrocarbons. Good, very good. Okay, so the aryl halides. So arenes are what? So these are the haloarenes are halogen derivatives of aromatic hydrocarbons in which, okay, in which again one or more hydrogen atoms is replaced by what? It is replaced by a halogen. It is replaced by what? It is replaced by a halogen atoms. Okay. So how do you represent the aromatic hydrocarbons? Okay. So here I'll write it ARX. Okay. ARX. So this represents your haloarenes. Okay. Now in this, the halogen atom, AR means what? Your benzene ring. Suppose I write the structure of benzene ring here. Okay, so this is a benzene ring. So the halogen atom is attached to the benzene ring. So what is the hybridization of this carbon? Can you tell me?
sp2.
Yes, it is sp2. So what are haloarenes? So haloarenes, they are called as the aryl halides. Okay, these are the halogen derivatives of aromatic hydrocarbons in which one or more hydrogen atoms are replaced by halogen atoms. Okay, and in such compounds, your halogen atom is attached to the sp2 hybridized carbon atom. Okay, is it clear? Yes, the definitions are clear. So here you can see the general formula to write the haloalkanes and haloarenes. It is given here. Yes, is it clear? The definitions are clear. Okay, fine. So moving to the next. So this is the haloalkanes and haloarenes. So next we are going to start with the classification. Next we are going to see what? Classification of halogen derivatives. Okay. So what are the classification? So first classification is based on the number of halogen atom present. So we know, okay, the halogen atoms, any number of hydrogen atoms can be replaced. So based on how many halogen atoms are present, so this is the first classification. And the second is based on the nature of the carbon to which the halogen atom is attached. So either the halogen atom is attached to a sp3 hybridized carbon. Okay, if the halogen carbon is attached to a sp2 hybridized carbon. Okay, so based on that. So these are the two classification. So first is on the basis of number of halogen atom. Okay, so both the haloalkanes and haloarenes, they are classified as monohaloalkanes or monohaloarenes, okay, or dihaloalkanes or dihaloarenes, trihaloalkanes or trihaloarenes, or polyhaloalkanes or polyhaloarenes, based on the number of halogen atoms. So if there is one halogen atom is replaced, okay, one of the hydrogen atom is replaced by halogen, then it is mono. If two hydrogen atoms are replaced by halogen atom, then it is di. If three hydrogen atoms are replaced by halogen atoms, then it is tri. Poly means more than three. Okay, if more than three hydrogen atoms are replaced by halogens in the structure, then they are called as what? Then they are called as polyhaloalkanes. Okay, they are called as polyhaloalkanes. So, so this is the first classification. Okay, so here, okay, so based on the number. So we'll see the example. So first, so can you tell me what is this? Yes, first example. What is the?
Ethyl halide.
No, I don't want the name. Okay, you can tell me whether it is mono, di, tri, what it is.
Dihalide.
How di? Only one of
Ma'am,
the
mono.
Monohalide.
yes, it is a monohaloalkane. Okay, please say it properly. So it is a monohaloalkane. Okay, it is a monohaloalkane. Now, this one. So this is a, you can see. Okay, two of the hydrogen atoms are replaced by halogen atoms. So it is a dihaloalkane. Why alkane? Because it is a straight chain compound. You can see it is a straight chain compound. There is no ring. So it is a dihaloalkane. Now here you can see, three hydrogen atoms are replaced by three halogen atoms. So here, how many halogen atoms are present? Three. So it is trihaloalkane. So based on the number of halogen atom, okay, one, here it is two, and it is three. So they are classified as mono, di, tri, or polyhaloderivatives. Okay, so this is the first classification based on what? Based on the number of halogen atom. Okay, now here, this particular example, one halogen atom and it is a arene. Okay, so it is a monohaloarene. What it is? Monohaloarene. Okay, it is a arene system. Okay, now next. Okay, next here, I'll write the structures. You need to tell me. Okay, this, what it is?
Dihaloarene.
Yes, it is a dihaloarene. Okay. Here,
Monohaloalkene.
yes,
Trihaloalkene. Trihaloarene.
arene. Okay, trihaloarene. It is a trihaloarene. So this is a trihaloarene system. Okay. So this is a dihaloarene. So, okay, so this is a classification. Okay, so based on the number of halogen atom, okay, and whether it is aliphatic or aromatic, so this is a classification. Okay, so this was the first classification based on the number of halogen atoms. Next is on the basis of the nature of the carbon to which the halogen atom is attached in halide. Okay, so this monohalo compounds. Okay, so these are further classified. Okay, based on the number of halogen atom. So whether the compound is sp3 hybridized. So whether the carbon is a sp3 hybridized. Okay, then these such a compound. Now suppose I have a halogen atom. Okay, I have a halogen atom. Now I'll write it besides that only, then it will be more clearer. Okay, I'll take this color. Okay, so here, okay, so so on the basis of the nature of carbon to which the halogen atom is attached. So first we are discussing the carbon if it is sp3 hybridized. Okay. So here the halogen atom. Okay. So the halogen atom is bonded to a alkyl group. Okay. It is attached to a alkyl group and they are further. So on the basis of the carbon to which it is attached. Okay, either it is a primary alkyl, secondary alkyl, or tertiary. Now, do you know what do you mean by primary carbon? First, I will teach you that. Okay, primary carbon, what is meaning of secondary carbon, and what do you mean by tertiary carbon? Okay, first we'll discuss this. So, if the halogen atom is attached to the carbon, okay, to another carbon. So this is what? Now this is carbon. So alkyl group can be your any alkyl group. Okay, it can be your methyl group. Methyl group is CH3. Okay, or ethyl group CH3, CH2. So this is a ethyl group. So any propyl group. So your E will be replaced by YL. Okay, so it is called as what? It is called as alkyl. Now here, so when the carbon is attached to only single carbon atom, okay, one alkyl group, then it is called as what? This is called as, it is a primary alkyl halide. What it is called as? It is called as primary alkyl halide. Okay. Now, what do you mean by secondary? Secondary means the carbon is attached to another two alkyl groups. Okay. So the halogen atom is attached to the carbon with two two alkyl groups. Okay. So it is a secondary alkyl halide. So this is a second classification. Secondary alkyl halide. Now what do you mean by tertiary? Tertiary means your halogen atom is attached to the carbon which is having three alkyl groups. Okay, it is having three alkyl groups. Then it is called as what? It is called as a
Tertiary
tertiary.
carbon.
Yes, it is called as tertiary alkyl halide. So this is a tertiary alkyl halide. Why alkyl halide? Because the carbon is having a halogen atom which is next to three alkyl groups. So this is the first classification. Okay, so they are when your compounds containing sp3-CX bond. Okay, so alkyl halides or haloalkanes. So based upon the what halogen atom is bonded to how many alkyl groups, it is classified as primary carbon, secondary, and tertiary alkyl halides. Okay, so it is based on what? This is based on the nature of carbon atom to which it is attached to. So this classification is clear. Okay, so we are discussing the first one. So we have completed this. So if the carbon is sp3 hybridized atom, okay, so based on the halogen atom to which the carbon is attached. So if it is attached to only one alkyl group, it is primary alkyl. If it is attached to next to a two alkyl groups, then it is secondary alkyl group. And if it is attached to three alkyl groups, then it is a tertiary alkyl halide. Okay. Then next, if it is having sp3 hybridized CX bond, okay, then their further second classification is as they are classified as allylic halides. Okay, so in allylic halides, okay, the compounds in allylic halides, so you can see the primary alkyl how it is given. So here you can see, so this is the, so you can see here, right? So the halogen atom is attached to a carbon with one alkyl group. The halogen atom is attached to the carbon with two alkyl groups. So it is called as secondary. So this is a secondary carbon. So the nature of CX bond is sp3 hybridized. Why sp3? They're having single bonds. Okay. Now here the halogen atom is attached to a carbon with three alkyl groups. So it is tertiary. So next is what we are studying about the allylic halides. So next we are going to study about allylic halides. Now what do you mean by allylic halides? Okay. Yes. So if the carbon is sp3, okay, CX bond, what is allylic halide? So in allylic halides, okay, the halogen atom, so important, okay. So in this compounds, halogen atom is bounded, it is bounded to sp3 hybridized, it is bounded to sp3 hybridized carbon atom next to carbon double bond. Okay, carbon double bond, that is allylic carbon. It is allylic carbon. So this is the definition, okay, of allylic carbon. So you can see, so what is happening? The halogen atom. So this is examples. So these are the examples. Okay, so this is example for a haloarene, and this is example, haloalkane, and this is example of haloarene. Okay, now allylic halides. So in this compound, what you can see, the halogen atom. Okay, the halogen atom is bonded to sp3 hybridized carbon, right? It is sp3 because this is having a single bond. So it is halogen atom is attached to the carbon with sp3 hybridized carbon atom, which is present next to a carbon-carbon double bond. So a double bond is present. So this such a compound is called as a allylic halides. What it is called as? It is called as allylic halide. Okay. So how it is written? I'll write it again. So CH2 double bond CH. Okay. and CH2X. So I've just written like this. So halogen atom is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. So this is a allylic halide. Now with respect to your haloarene, okay, halogen atom is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. Is it clear what is allylic halides?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is the meaning of allylic halides. Fine. Next. Okay. So next classification. Okay, we'll see behind what was the next classification. The next is benzylic halide. So the third one is what? A we have seen, then B, and this is a C. Benzylic halides. So what do you mean by benzylic halides now? Okay, here you can see down one. Benzylic halides. So in this compound, okay. So in this compounds, halogen atom, the halogen atom is bounded to sp3 hybridized carbon atom next to aromatic ring. Now I'll explain you with the your example. Okay. So the halogen atom is attached to a sp3 hybridized carbon, which is next to a aromatic ring. So such compounds are called as what? Benzylic halides. Okay, such a compounds are called as what? Benzylic halides. Is it clear? What do you mean by benzylic halides? I hope you are noting down the things. Okay, don't get confused. So these are the basics. And based on this, further we are going to use. So later I won't be explaining again and again. Allylic, what is allylic, what is benzylic. So if I consider a allylic halide, so you have to imagine and you have to understand. Okay, allylic means what? The halogen atom is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. What do you mean by benzylic? In benzylic compounds, the halogen atom is bonded to a sp3 hybridized carbon atom, which is next to a aromatic ring. Okay, so like this, you have to imagine the things. Okay, is it clear? What is benzylic halides?
Yes, ma'am.
Okay. I hope others have also understood. Okay.
Yes, ma'am.
So next is compounds containing sp2 hybridized atom, that is CX bond. Sp2 CX bond means what? The halogen atom is attached to a carbon which is next to a carbon-carbon double bond. So like this. So when you have such type of nature of carbon atom to which the halogen is bond. So these are further classified as vinylic halides and aryl halides. Okay, so there are two classifications. So please note this down: vinyl halides and aryl halides. Okay, so we'll see what are vinyl halides and what are aryl halides. Okay, so these are the examples of vinylic halides and arylic halides. So what do you mean by vinylic halides? So the first classification and second. So vinylic halides. Okay, so these are the compounds in which halogen atom is bounded to sp2 hybridized carbon atom of CC double bond. Okay, so this is a definition of what? Vinylic halides. So this is example. So what is that? Halogen atom. Okay, it is attached to a, it is bonded to the carbon, which is sp2 hybridized. Sp2 means what? It should have a double bond. So this is the example. So these are the vinylic halides. So halogen atom is attached to a carbon, which is sp2 hybridized atom of a CC double bond. So this is an example of what? Vinylic halide. So don't get confused. What is allylic halides? What are benzylic halides? What are vinylic halides? And what are aryl halides? So these are the four important types of this halides. Okay. Don't get confused. I hope you are writing down the definitions. Okay. So that you don't get confused. So compounds in which the halogen atom is bounded to sp2 hybridized carbon atom of a double bond, CC, carbon atom of a CC double bond. Then they are called as vinylic halides. Next is what? Aryl halides. Next is what? Aryl halides. So what do you mean by aryl halides? So aryl halides, compounds in which halogen atom is bounded to sp2 hybridized. It is bounded to sp2 hybridized carbon atom of an aromatic ring. Is called as what? This is called as aryl halides. These are the definition of what? Aryl halides. Okay. So we'll see the example. Okay. So the halogen atom is bonded to a sp2 hybridized carbon. sp2 means it is having a double bond. So of a aromatic ring. So they are called as aryl halides. One more example. So this can be also example of aryl halides. So halogen atom is attached to a sp2 hybridized carbon of an aromatic ring. Are these definitions clear? Yes. Please go through all the definitions, and if you have any doubts, you can ask me. Okay, take 2 minutes and just recall all the definition. Yes, so we have discussed what is allylic halides. Okay, what is benzylic? Okay, it comes under the carbon atom. Okay, if the CX bond is sp2 hybridized. Okay, in sp3 hybridized, sorry, in sp3 hybridized, your allylic halides and your benzylic halides will come. And if the nature of the carbon atom, that is CX bond, is sp2 hybridized, in that your vinylic halides and aryl halides will come. Okay. Is it clear? Yes. Any doubts? Okay. Fine. So we'll go. So for your syllabus, okay, you have only based on the nature of carbon atoms, that is if it is sp2 and sp3. Okay, sp is not there for you, that is alkaline halide, so we'll not discuss this and get confused. So you have only this. Okay, sp3 and sp2, you don't have sp. Okay,
And once again, tell me benzylic definition.
benzylic. Okay, benzylic halides. Okay. So benzylic, where it comes? Benzylic, if the nature of the carbon atom is sp3 hybridized. Okay. So what will happen in this compounds? In this compounds, the halogen atom is attached to a sp3 hybridized carbon. It is attached to a sp3 hybridized carbon. Okay. Of an next to an aromatic ring. Now see what is the difference in aryl halides and in benzylic halides. So in aryl halides, your halogen atom is attached to a sp2 hybridized carbon of an aromatic ring. Directly the halogen atom is attached. In benzylic halides, the halogen atom is attached to a sp3 hybridized carbon, okay, next to a aromatic ring. So this is a difference. Understood? So this is a benzylic halide. Okay, this is a benzylic halides and this is a aryl halide. So this is a difference. So here in aryl halides, it is directly attached. The alkyl halide, the halogen atom is directly attached to a sp2 hybridized atom of an benzene ring. And in your benzylic halides, your halogen atom is attached to a sp3 hybridized carbon of an next to an aromatic ring. Is it clear now?
Yes, ma'am.
Yes, ma'am.
So these were the classification. The monohalogen. Okay. Okay. See here. So this we know that whenever you have a one single halogen atom attached to a alkane, then it is called as monohalogen, and these are termed as alkyl halides. So based upon the type of alkyl groups. What is alkyl groups now? When you have methane, okay, one of the methane. So this is what methane, right? So in what will happen? One of the hydrogen will be replaced. Okay, so one of the hydrogen is removed, and what will so your ane, okay, your ane will be replaced by YL. So it will be what? It will be methyl. So it becomes CH3. So when one of the hydrogen is removed, same with respect to this CH3, CH3. Okay, so this is what? This is ethane. Okay, so when you remove your ane and when you remove one of the hydrogen, this results into CH3, CH2. This is what? Ethyl group. Same way with respect to what is the formula? It is CnH2n plus 2. Okay, so if the number of carbon atoms is 3, n is equals to 3, what you get? C3H2 into 3 plus 2. So this will be C3H, 2 3 is a 6 plus 2 8, C8. So this is what? This is propane. When carbon number is 3, it is propane. When number of carbon atoms are 4, then it is butane. If it is 5, it is pentane. If it is 6, it is hexane. 7, heptane. Octave. 9 is nonane and 10 is decane. Okay, like this. So one of the hydrogen, now when it becomes ane is replaced by, okay, and you remove one of the hydrogen, so it will be C3H7. So this will become what? Propyl. Okay, so based upon the alkyl groups, so it okay, so it is, the name is derived. So here CH3Cl, so it is what? Methyl chloride. Now, CH3, CH2 is what? It is a ethyl group. And this is a bromine. So, it is a ethyl bromide. Now, CH3, CH2, CH2. So, when N is 3 and one of the hydrogen is removed, okay, it is a propyl iodide. Okay. Now, here. So, this all you have studied in first year. Okay. For hydrocarbons, how the naming is given. Now, here, the number of carbon atom is what? 1, 2, sorry. Yes. So, 1. So here it is 1, 2, 3, and 4 carbon atoms are there. And it is in a iso system. Okay. You can see it is a iso system. So carbon is attached to next 3 carbon atoms. So it is a 1, 2, 3 tertiary carbon. So it is a isobutyl chloride. So like this. So depending upon how many carbon atoms are attached, alkyl groups are attached. So this is the naming given. Okay. So this all things we have discussed. Okay, preparations we'll see later. Next is the nomenclature. Okay, next we are going to study about the nomenclature. Nomenclature means what? What do you mean by nomenclature?
Naming a compound.
Yes. So how to name the compound? Just a second. I'll take a new slide itself here. current slide. Okay. So now we are going to see the nomenclature. So the classification is clear. Okay. So we'll start with nomenclature. So in common system, okay, in common system, the name of the alkyl halides, okay, they are derived how? They are derived by first naming the alkyl group. So when you are doing in common, so when common names are given, so when common names are given, okay, in the common system, first you have to name the alkyl group. First name your alkyl group. Okay. Then followed by what? Followed by name of halide. Followed by name of halide. So this is the the okay, in this system you can use the prefix. Prefix means what? The word which is added before the name. Prefix means you add it before the name. Okay. Have you put Miss, Mr, like that? So that way you can keep in mind. So what is prefix? You add it before your name, okay, of name of the compound. So prefix. So what are the prefix used? Like N, okay, iso, then ter, okay, tertiary, and neo, etc. So these are used to indicate the isomerism. So what it indicates? It indicates the isomerism. Now what do you mean by isomerism? Isomerism means what? The number, the structural, the molecular formula remains the same. The change will be in the structural formula. Okay, so this is called as isomerism. So suppose I have N-butane. So CH3, CH2, CH2, CH3. So this is what? Number of carbon atoms are 4. So this is a butane. So when you have the inner state chain, then it is called as N-butane. Suppose the same way CH3, CH, CH3, okay, and CH3. So this is what? This is a isobutane. Okay, it is a isobutane. So like this, the names are given. So based upon the number of isomerism. Okay, so the molecular formula in the both the cases it is same. Only the change is in the structural formula. So based upon the molecular that is a isomerism, that is a change in the structural formula. The what is given? Prefix name is given. Okay, so this is in case of what? Common system. Now we'll see in case of the what? IUPAC system. What is the full form of IUPAC, students? What do you mean by IUPAC? Yes, anybody knows what do you mean by IUPAC?
International Union of Pure and Applied Chemistry.
Correct. Good. Okay, so it is an international union of applied and union of pure and applied chemistry. Okay, so this is the meaning. So according to this, the so we follow the IUPAC system. So in IUPAC system, they are named as halo substituted. Okay, they are named as what? Halo substituted hydrocarbons. So halo substituted, because what is happening in your hydrogen atoms? Okay, they are replaced by the halogen group. So we are naming it as halo substituted hydrocarbons. Okay, we are naming it as halo substituted hydrocarbons. Fine. So that is, they are called as haloalkanes. They are called as what? Haloalkanes. Okay. Now in case of aryl halides, okay, in case of aryl halides, what they're called as? They are their common name, IUPAC name, as well as the common name is haloarene. Okay, the IUPAC name as well as the common name, they are derived as haloarene itself. Okay, now we'll see some of the this. We'll see a tabular. Okay, so I'll write the structure, then common name, and their IUPAC name. So try to give the name of that. Okay. So what is this structure? CH3, CH2, CH2, Cl. So I'll keep on writing one all you can answer.
Chloro 2 methyl.
Okay, let me see who is answering. Okay. Now you can answer.
Chloro-2-methyl ethane.
No. I just told you how to name the system. Common name, how to name. Common name should be given. First, write the alkyl group. Then you have to write the, what is that? Halogen. And before that name, it will be your prefix. If it is a straight chain, you have to write N. Okay. If it is in the branch system, then iso. See here, how do you name it? Okay, I'll tell you first three, then you'll come to know. So
N chloropropane, ma'am.
N,
N chloropropane.
no, you have to follow first what? Yes, N is correct. Okay, then you have to first write the alkyl group. So first will come your N propyl chloride. Okay, N propyl chloride. So N propyl. So first will be your alkyl group and then followed by a halogen. And okay, and in the prefix you have to write based upon the isomerism. Okay. Then what is the IUPAC system? In IUPAC system, you have to write halo substituted. At one position, you have one chloro, then you have propane. So this is the IUPAC system, halo substituted. Okay, haloalkanes. So at what position your halogen is substituted? At one position. So one chloropropane. Okay, similarly, this one, can anyone tell me? So this is in the form of branch. So it is iso.
Isopropyl chloride.
Yes, isopropyl chloride. Good. Okay, isopropyl chloride. Now, IUPAC system, at what position the chloro is substituted?
2.
Yes, 2. So it is
Two
2 chloro.
chloro.
Yes, 2 chloropropane. Good. Yes, good. Okay. Now, third one. So 1, 2, 3, and 4.
Sorry.
N butyl chloride.
N butyl chloride. Good. IUPAC name? At what position?
Chlorobutane.
At what position?
1 chlorobutane.
Yes, 1 chlorobutane. Good. Okay. So like this, you have to remember the, you have to write the IUPAC and this. Now, next one is CH3, CH2, CHCl, and CH3. Okay. One more I'll write. It will be CH3C. CH3 thrice. Okay. It is CH3 thrice. Then CH2. Yeah. Okay. Now you can tell me. So I have written 2 more. Okay.
Ma'am, isobutyl chloride.
No, not iso. Your, it is not branched. Okay. Your chloro is substituted. Your, this is not substituted. What? What is that? Your alkyl group is not substituted. Chloro. So what you have to see? You have to see the carbon. So carbon is attached to another 2 carbon atoms. So what type of this it is? What type of carbon it is? Primary, secondary, or tertiary?
Second.
It is a secondary carbon. So you have to write secondary. Now, substitution 1, 2, 3, and 4. So whenever you are writing the numbering, you have to see that you are substituted. Now your fluoro is substituted, right? So the substitution should get the least number. So I am writing like this. Okay. So whenever I am writing, so your substituted atom, the halogen atom, it should get the least number. So 2. Now what it will be? Secondary.
Secondary butyl chloride.
Yes. Okay. Can you tell me the IUPAC name?
2-butyl chloride.
No,
2
wrong.
chlorobutane.
2-chlorobutane. Yes, correct. Okay. 2-chlorobutane. Okay, next. So this is important, asked in most of the papers, in the previous papers. Okay, give the IUPAC name of this compound. So it is important. Mark this as important. Yes, what is the name? I'll give the numbering. Shall I give the numbering? Okay, let me give the numbering. So the numbering starts from so 1, 2. Okay, 1, 2, 3. Yes, now.
Tertiary.
Isopropyl bromide.
Not tertiary. Isopropyl. No. Which are looking? Okay, CH3. Okay, just a second. CH3, CH2, CH3 thrice, CH3C, CH3 thrice, CH2 Br. Okay, correct. So new. Yes, try. I'll tell you. You try.
Isopropyl bromide.
No. Okay, somebody 2,2-dimethyl bromopropane. 2,2-dimethyl bromopropane. Okay. See here, whenever you're numbering here in IUPAC, okay, Yamuna has answered. Who has answered? Yes, Yamuna. So your first your substituted substituted name should come. Your answer is correct, but just make a bit changes in IUPAC name. You are answering IUPAC name, it is correct. Okay, just the halo substituted should come first. See here. So here 1-chloro, 2,2-dimethyl propane. 1-chloro. Where is chloro here? We are seeing this compound, last compound. Okay, see here, let me tell you common name. See, whenever the prefix here, no, Shri Suresh, no. Okay, let me tell you. Okay, see here, whenever the carbon atom is attached to 4 carbon atom, okay, next to 4 carbon atom, you can see. So then the this will come as neo. What the word will come? The prefix will come as neo, Neo. Okay, so neo.
What is neo, ma'am?
That is only that the carbon atom when it is attached to 4 carbon atoms. Right, you can see in the structure. Wait, let me erase this all. Did you note down the other things? Should I clear? I'll write only this last structure above. Okay, see here. This. See here. So C, CH3, CH3, CH3. Okay, and then comes here CH2, Br. Okay, so what is happening here? Your carbon atom. Okay, so carbon is attached to 1, 2, 3, 4 carbon atoms. So it is called, the word prefix is given as neo. So neo, it is whenever the isomers, okay, in the carbon atom is attached to 4 carbon atom, then it is given the word as neo. So neo, how many carbon atoms? 1, 2, 3, 4, 5. So it is
Butyl.
pentyl bromide. Okay, neopentyl bromide. Now the IUPAC name. So 1, 2, and 3. So it is Okay, one bromo, listen, one bromo, then at 2 position. How many groups you have? 2 position, you have methyl groups. How many methyl groups? At 2 position, you have 2 methyl groups. So it is 2,2 dimethyl. Okay, 2,2 dimethyl. Then the parent is 1, 2, 3 propane. Okay, so the parent chain is propane. So this is very important. As I said, for 1 marks, it is asked. Okay, give the IUPAC name. So this is asked in the IUPAC system. Okay, next one.
Ma'am, give example about tertiary, ma'am.
Yes, yes. Next, I am taking that. Okay. So carbon. So next, we are going to take the molecule. So this is also important. Next molecule for 1 mark, it is asked. Okay. So CH3, 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 and Br. Okay. Now you name this. Name this compound. Name this compound. Carbon is attached to how many carbon atoms? Okay, let us finish this fast. Yes.
Neobutyl bromide.
Why it is neo? Is it attached to 4 carbon atoms? The center carbon, it is attached to only 3 carbon atoms. When it is attached to 3, what is the name?
Tertiary.
Yes, it is a tertiary. Okay, so tertiary, how many carbon atoms? 4. So tertiary butyl, then bromide. Okay, then IUPAC name. What is the IUPAC name?
1 bromo.
Okay, if I give the name, just me see you. Okay, so whenever you are considering the IUPAC name, okay, that time you have to take the highest number of what do you say? Parent, this, right? Parent chain. So the number of parent chain most, this will be, okay, so this, the number, you can see in the parent chain, the maximum number of carbon atoms will be your 3. Okay, so now you can name. Yes.
1 bromo.
No.
2 dimethyl.
Here,
methane.
see the numbering. Is the bromo present at 1?
2 bromo.
Okay. Next, 2 bromo.
2 methyl
Yes.
propane.
Then, yes, good. Sri Suresh has answered. Yes, good. Okay, so 2 bromo, 2 methyl. Then the parent chain is 3 carbon atoms. So it is propane. Okay. So very important. So these two structures are very important. Next.
Go to number chain, ma'am.
Huh? What happened? See at, okay, let me explain you if you did not understand. See here, now when I'm writing the numbering here, okay, so tertiary butyl bromide is understood because carbon is attached to 3 other carbon atoms. So it is a tertiary carbon. Number of carbon atoms are 4. So butyl bromide. Now when we are writing this, okay, we have to see the longest carbon atom chain. So if we take these two, okay, if I take like this naming, if I number it, so it will be only 1 and 2. Okay, and always the longest chain will be what, like this. It will not go like this. Either it will be like this. So it will see the number of carbon atoms should be maximum in the parent chain. So when I'm writing here, now what I'll see, if I consider like this, so it will be 1, 2, and 3. So at 2 position, I have bromo. So 2 bromo. Then at 2 position, I have this methyl. So 2 methyl, and then this one propane. Yes, the molecule is covered. So this is the structure. Okay.
Ma'am, why are you not applying in horizontal type of number?
Whatever. Which one?
Number chain.
Uh,
Why are you not applying in horizontal?
which, like this?
Yes.
Because see here, how many carbon atoms will be there if I consider like this? 1 and 2.
Yes, ma'am.
Right. So whenever I'm taking the parent chain, I have to see that maximum carbon atoms are covered in a parent chain. So parent chain should be maximum the longest chain. We say that longest carbon chain, right? So for nomenclature, again, please open your first year books, okay, and study the nomenclature properly. Very important, okay, nomenclature, because hence after we are going to discuss in all the chapter, that is all the chapters, okay, henceforth in second year. So first will be your nomenclature. So that time so all these rules will be applied. So all these things you have studied in the first year. So you have to see the longest chain. So when I apply here, it will be 1 and 2. Okay. Then, so if I consider like this, it will be 1, 2, and 3. Like this. So I take it vertically. Okay. So these are two important compounds. Okay.
Okay, ma'am.
I'll give you structures. You find the answers for this tomorrow. Okay. Now it is already time up, so I'll give the structures for you. So please note this down. We have last 2 minutes. So just note this down. Okay. So that you can answer this in the next class. These are the structures CH2, Cl2, and okay. So I have given you 1, 2, 3, 4, and 5. So don't remove your textbooks and see these answers. Huh? I want you all to apply whatever things we have studied. So based on our whatever things we have studied today, so you have to apply. If it is wrong also, it is fine. But don't open the textbook and tell the answers. Is it okay? So whatever things have been told today, is it clear?
Yes, ma'am.
Yes,
Okay,
ma'am.
fine. So I'll end the session here. Okay, we'll continue with the same in tomorrow's class. I hope you have written down the molecules. Okay, so write the structures. So in the next class, we will discuss the common name and IUPAC. Okay, so thank you. We'll end the session here. We'll meet in the next class.